All right, Chapter 2 deals with equations and inequalities. Section 2.1, we're going to be talking about the rectangular coordinate systems and graphs. I am not going to go into specific details on how to graph in our rectangular coordinate system. Some of it's pretty basic, but if you need to refer to your textbook, you'd want to look at Section 2.1 for additional information. One of the things you'll be asked to do is to find the x and y intercepts. Now, you have heard me say many times last year and ask you the question, how do you find the x-intercept? You let y equal 0, and you solve for x. So in order to do that, one of the ways we did that, if it was in standard form, in which case we have our x's and y's on the same side and our whole number on the other, we did kind of like that little cover up. Imagine if y is 0. Well, if y is 0, then that's gone. And we just are solving 3x equals 6, and we get x equals 2. So we can kind of see that visually very easily. So my x-intercept, if we let y equal 0, we get x equals 2. But you're going to be asked to write this as an ordered pair. So that would be the point, the coordinate would be the point 2, 0. To get my y-intercept, I let x equal 0. I can think of it this way if I want to, as long as it's in the right format. If I let x equal 0, that term's gone, and I get y equals -3. So we'll have y equals -3, and if I write that as an ordered pair, I get the point 0, -3. Now, if I were graphing these and plotting these points, these would be the points I would plot. So on this next one, what if it's not in standard form? I would say put it in standard form. I mean, there's more than one way because you could solve it algebraically. You let x, this actually, to find the y-intercept, let x equal 0. And if you do that, you get 0 plus 6, which is 6. So we know the y-intercept is 0, 6. To find the x-intercept, you're going to let y equal 0. Well, you can do the algebra, and that's okay. You can do it that way. Let y equal 0, and then solve for x. So I would subtract 6 and divide by -3. So I would have the point 2, 0 for the x-intercept. You could also put it in standard form, make it look like that, and then do the little cover-up method. You might be asked to solve for a variable in terms of another variable. Now, this is a very simplified version of that, but we're going to solve for y in terms of x. That means get y by itself. So I'm going to start by subtracting 5 from both sides. So I get 2x minus 5 equals -3y. But I want to solve for y, so I need to divide each side by -3. And so now I'm going to have the y by itself, and I'm going to switch those around. So I'm going to take 2/3 divided by -3. Because it's a common denominator down here, I can split it apart. We've done this before. So I'm going to write this as -2/3 x. And then I have a -5 over -3. That's going to make that plus 5/3. Now, you wouldn't have to do that. If you wrote your answer, y equals 2x minus 5 over -3, technically, you have satisfied what you've been asked to do, solve for y in terms of x. You did. You solved for y in terms of x. This is nice because it's in slope-intercept form. So if you were going to be doing other things with this equation, which likely you would be, you've already got it in a nice form that you can graph that. Find the distance between the points. -4, 1, and 3, -4. Now, you probably remember, well, you might not, but from geometry, you had a distance formula. I choose not to really memorize the distance formula because if you think about what really that is, let me just kind of sketch a little graph here. -4, 1 is going to be in quadrant 2, and I'm just going to kind of plot somewhere where it would be. So let's call that -4, 1. And 3, -4, might be down here. It's going to be down here somewhere in quadrant 4. So 3, -4. And we're finding the distance between those 2 points. Well, if you build a right triangle, and then you see the distance between the x values between a -4 and a 3 is 7, and the distance between a 1 and a -4 is a distance of 5. This is just the Pythagorean theorem. So it's a right triangle. So if you want to know this side, you're going to take the square root of 7 squared plus 5 squared. So we get the square root of 49 plus 25, which is the square root of 74. And we would need to think, can this be simplified? So if you break down the 74, you get 37 times 2. And since 37 is prime, this cannot be simplified. So this would be the distance. So you do have a formula, the distance formula, and you had something like, x2 minus x1 quantity squared plus y2 minus y1 quantity squared. You took the square root of that. But that's the same thing that we did up here. The distance, the difference, or the distance between the x values, that's what this is. And the distance or difference of the y values, that's what this is. So just recognize this is just the Pythagorean theorem. It is not some additional formula you've had to memorize. Most of you remember the Pythagorean theorem. Here's another one. Find the coordinates of the midpoint of the line segment that joins the points -1, 1 and 7, -4. So we're finding a midpoint. There's a fancy formula for that, but I tend to think of it like this. Average the x's and average the y's. So to find an average, you add and divide by 2. So we're going to get -1 plus 7 divided by 2 and 1 plus -4 divided by 2. So we get 6 over 2 is 3, or -3/2, and there's your midpoint. Okay, so just think of it averaging. This example asks us to construct a table and to graph the equation. So if it's not given to you in slope-intercept form, or we're creating a table, I find it much easier to actually solve for y. So solve for y in terms of x, which is why you had to do the other problem like that. So I'm going to divide by 2. I'm going to get 1/2 x plus 3/2, and then I'm going to create a table. So I'm choosing values of x. Since I'm choosing these, this is called the independent variable, and y is called the dependent variable, because y, my values of y, depends on what I pick for x. So you can kind of think of it that way. Now, when I pick values for x, I am going to pick, well, actually, maybe it wouldn't really matter. If a lot of times I would say I would make smart choices, like I might pick a 6 or an 8 evens because of this 2 down here. But because I have a 3/2 here, it probably doesn't make a difference. I usually will pick like a 0. Plugging in a 0, I get 3/2. That's easy to do. You might try I'm going to pick a 3, because then I get 3/2 plus 3/2. And 3/2 plus 3/2 is 6/2, which is 3. And let's just pick one more value just to double check. And so if we have, I'm going to pick a negative value. So I'm going to pick a negative, I'll do -3. So if I plug in a -3, I get -3/2 plus 3/2 is 0. So those are some nice points that I can pick. And then we're going to go ahead and graph that. Maybe. There we go. So let's graph these values, and then we'll make a line. So you might wonder, well, why did I pick 3 points? I could have done this with 2, and that is true. But by picking the third point, it just allows me to make sure, because if I made a mistake with the math, I'm going to notice I don't get a line if I make a mistake there. But with 2, I might not notice. I wouldn't notice that. So the other thing I'm going to make sure I would really like you to always do is scale your graph. So I'm going to plot a 1 right here and a 1 right here. So anyone looking at this would know that I was counting by 1s, because sometimes you might find yourself counting by 2s or 5s or something to make the numbers more manageable to fit on your graph. You might scale your x's by 2s and your y's by 5s. That's a possibility. So just show me what you are graphing, what your scale is. So now I'm going to plot 0, 3/2 and 3, 3 and -3, 0. And you'll see that they line up. And then I can draw my line. Okay, now the reason why I connect the dots is because I could have picked anything. I could have picked any values for x and gotten values for y. I was not limited to these 3 points, so that is why I'm allowed to connect those dots. Later we'll be talking about domain and range, but I'm sure you remember from algebra, in this case the domain and range would both be all real numbers. And our next example, graph the equation by finding the x and y intercepts. So if I had it in this form, probably what I would do first is put it into standard form. So I'm going to multiply both sides by 2. So I get 2y equals, the 2's cancel here, so I get x minus 3. And then I'm going to go ahead and get everything on one side. I think what I'll do is I'm going to reorganize this. Hopefully you'll see what I'm doing, because I'm going to have x minus 2y. If I bring the 2y to this side and move the 3 over here. So, you know, we're in college algebra now, so we're a little step above honors algebra 2, so hopefully you can follow those steps when I rearrange that. So then to find the x and y intercepts, I can see right away if I let y equal 0, I get x equals 3. So my x-intercept is 3, 0. And for my y-intercept, if I let x equal 0, I'm going to get y equals negative 3 halves. So I get 0, negative 3 halves. So I'm going to go ahead and plot those. Don't forget to do this. I almost did. And maybe we can adopt the convention that if I don't see a scale, I'm going to assume you count by ones. But if you are not counting by ones, you must show me the scale. So 3, 0, 0, negative 3 halves. And now it's aligned, so I can go ahead and connect those. My arrows show it keeps going. And there's my line with that x and y intercept. Now this method will not work in a certain situation. If our problem had been something like 2x plus 3y equals 0, we would not have been able to use this method to graph it because the x and y intercept is 0, 0 for both of them. So we had that situation. So then we would have to adopt a different strategy. If we needed to graph it, we wouldn't be able to do it with that method. And that is it for section 2.1.